Okay, first question. Remember that in order to sketch the graph of this function, first of all, we need to convert it to vertex form, right? So note here we have already had our a squared, and you should rewrite the term in the middle to 2ab, right? And apparently minus 7x can be rewritten as 2 times x times minus 7 over 2, right? So the other term b is negative 7 over 2. Okay, so you can try rewriting this to y equals x minus 7 over 2 squared. And on a scratch paper, if you extend this, you will get x squared minus 2ab, which is 7x plus b squared, which is 49 over 4, right? And two terms here are exactly the same as the two terms in the original expression, but there is no 49 over 4, so we need to subtract it. Then copy the rest of the expression. Okay, so now the function is rewritten in this form. Next step, we can just merge all the constants, which is negative 49 over 4 plus 24 over 4, which is y equals x minus 7 over 2 squared minus 25 over 4, right? Okay, remember that the vertex form has a form like this: y equals a times x minus h squared plus k. So this is our a here is 1, and h here is 7 over 2, and k here is negative 25 over 4. All right, so first of all, the vertex coordinate of the vertex is 7 over 2 and negative 25 over 4, right? And now you can sketch the vertex on the 2D system. So 7 over 2 is around here, and negative 24 is around here. So suppose this is our vertex. Okay, next step is to find its y-intercept. That means we need to let x be 0, right? If x is 0, we can insert x being 0 to the original expression, then y is apparently 6, right? Therefore, the y-intercept is 0, 6. So 0, 6 is around here. Okay, so far we have 2 points. Sorry, 2 points on the graph of the function. Next, we need to find its x-intercept. That means to let y be 0 and solve for x, right? If y is 0, that means x minus 7 over 2 squared equals 25 over 4. That means x minus 7 over 2 should be positive or negative 5 over 2. And if we choose positive 5 over 2, then x is 6. Or if we choose negative 5 over 2, x is 1, right? So that means there are two x-intercepts. One of them is 1, 0, which is here. The x-intercepts are 6, 0, and 1, 0. 1, 0 is here, and 6, 0 is about here, okay? All right, last, let's check the value of a. A is 1, and apparently 1 is greater than 0. That means this function is opening up, right? So the vertex is here, and opening up should have a trend like this. Okay, and usually we'll label the expression of the function next to the sketch, which is x squared minus 7x plus 6. Okay, so please have a look at this question. Let me know if you finish, okay?
Done.
Okay. All right, good. Let's see the next one. Okay, next question. You can rewrite this function to y equals -1/5 times x minus 0 squared, right? And plus 0. And this is already in a vertex form, right? So here a is -1/5 and h is 0. And k here is 0, right? Therefore, first of all, we have found the vertex of the coordinates of the vertex, which is 0, 0. And next, we need to find its x-intercept and y-intercept. So let's find the y-intercept first. That means let x be 0 to solve for y, right? And if x is 0, if you put it in the original expression, apparently y is also 0. That means the y-intercept is 0, 0. And in order to find its x-intercept, we can let y be 0, right? And solve y, to solve x. Okay, if y is 0, that means -1/5 of x squared is 0. And therefore, x is 0. Therefore, the x-intercept is also 0, 0. And apparently a is -1/5, which is less than 0. So this function will open down, right? We'll have a trend like this. Okay, so we have gathered all the information we need, and we can then sketch the graph of this function to the 2D Cartesian plane. Okay, so first of all, to find its vertex, which is 0 and 0. And it's here, right? 0, 0. And this is a vertex. And note that the y-intercept and x-intercept is also 0 and 0. So this point is a vertex, the x-intercept, and y-intercept as well. And start from here, the function opens down, so it will have a trend like this. Again, let's label its expression next to the curve. Okay, so this is a complete sketch of the graph of this function. Okay, any questions?
Okay, I got it.
All right, good. Let's have a look at the next one. Okay, next function. Note here the leading coefficient is not 1, right? Again, first of all, we need to convert it to the vertex form, which has a form like this: y equals a times x minus h squared plus k. So if the leading coefficient is not 1, first of all, we can put it in front, right? And what's left in the brackets are x squared minus 10x, then plus 53/2, right? And let's consider the expression in the brackets now. So first of all, we have already had our x squared, and term in the middle can be factored to 2 times x then times -5, right? So -5 here is the other term in the squared binomial. So we can try y equals 2 times x -5 squared. So if we expand it, it will get x squared minus 10x plus 25, right? first two terms are exactly like the first two terms here, but there is no negative, there is no 25, so you need to subtract it and then copy the rest of the expression. Okay, and then let's simplify. This is x minus 5 squared, then minus 50 over 2 plus 53 over 2, which is y equals 2 times x minus 5 squared, then plus 3 over 2, right? Then multiply 2 inside brackets, you will have 2 times x minus 5 squared plus 3, right? And as you can see here, this form here is already in a vertex form. So this is our A is 2, and H is 5. Here is a K is 3, right? So therefore, first of all, we found the coordinates of the vertex, which is HK. That means 5, 3. Okay, and at the same time, you can label the vertex on the 2D Cartesian plane, which is about here, 5, 3. So let's say 5, 3 is here. And then we need to find its Y-intercept and X-intercept. First of all, we can let X be 0 to find its Y-intercept. If X is 0, let's put it in the original expression. That means Y equals 53, right? That means the Y-intercept is 0, 53. Next, we can try to find its X-intercepts, if any. That means we can let Y be 0 to solve for X. We let Y be 0, it's better to put it here to find X, right? That means 2 times x minus 5 squared plus 3 is 0. That means x minus 5 squared equals negative 3 over 2. Apparently, something squared cannot be a negative number in the real number set, right? Therefore, no solution in real number set in R, right? Therefore, no X-intercepts. Okay, last, let's check the value of A. A is 2. According to the vertex form here, A is 2, which is greater than 0, right? So that means this function will have a shape that opens up. Okay, so back to the sketch here. First of all, mark the Y-intercept here, which is 0, 53. Okay, so basically we have 1 and 2 points on the curve, and this function opens up, and this is a vertex, so this function will have a shape like this, right? And let's label the function here next to its curve. Okay, so this is a complete sketch of the graph of this quadratic function. Also, I forget to label its axis of symmetry, right? Because the questions asks us to also label the axis of symmetry, which is x equals 5 in this question. Okay, so please have a look at this question and let me know if you finish and we can proceed.
Okay.
Okay, if you finish, let's have a look at question 4. Okay, question 4, the leading coefficient now is a negative number. When you have a negative number as a leading coefficient, you need to pay attention when you want to transform it in the vertex form, right? Okay, first of all, put the leading coefficient outside, and what's left in the brackets are x squared, then plus 4x, right? And then plus 5/3. So my suggestion is to verify your result by multiplying the negative 3 inside. So if you verify this now, you will get negative 3x squared, negative 12x, negative 5, which should be exactly the same with the original expression here, right? So that ensures the first step is correct. Okay, next step is to rewrite the expression here in the brackets into a squared binomial. And we have already had x squared here. And remember that term in the middle should be rewritten as 2 times x times something, right? Apparently 4x is 2 times x times 2. So this is the other term. So you can try rewrite this as x plus 2 squared, right? Okay. That means y equals negative 3, then x plus 2 squared. And in a on a scratch paper, if you expand it, you will get x squared plus 4x plus 4, right? The first two terms are exactly the same as the first two times is the original expression, but there is no 4, so we need to subtract it. And then copy the rest of the expression. And then simplify this. That means negative 4 is negative 12/3, then plus 5/3. And then y equals negative 3 times x plus 2 squared, negative 7/3. And then we can multiply the 3 inside brackets, which will get us negative 3 times x plus 2 squared, and then plus 7, right? Negative will get us positive 7. So that means the coordinates of the vertex is negative 2 and 7, right? As you can see here, leading coefficient A is negative 3, and H is negative 2, K is 7, right? So the vertex is negative 2 and 7. Okay, so now we can mark the vertex on the 2D Cartesian plane. So negative 2 is about here. And positive 7 is around here. Again, not necessary to scale as long as you keep all the elements to a correct relative positions. So here is negative 2, 7. This is a vertex, right? Okay, next, let's try to find its y-intercept. So that means let x be 0. So if x is 0, let's put it back in the original expression. That means y equals negative 5. So that means the y-intercept, the coordinates of the y-intercept is 0, negative 5, right? And next, let's find its x-intercepts. So that means we can let y be 0 and solve for x. So if y is 0, remember that it's better to put it in the vertex form to find the value of x's, right? So that means negative 3 times x plus 2 squared plus 7 equals 0. That means x plus 2 squared equals 7/3, right? And apparently x plus 2 can be positive or negative square root of 7/3. That means x can be negative 2, positive or negative square root of 21/3, right? Okay, so we need to give approximate value of x's. So first of all, consider negative 2 minus square root of 21/3. The square root of 21 is less than square root of 25, but greater than square root of 16, right? So it's around negative 3 point something something, right? You can give it a rough approximation. So apparently it's less than -2, right? So if it's less than -2, it's around here. So let's label this point here. And now let's consider positive 2 plus square root 21 over 3. And because square root of 21 over 3 is less than 2, right? Because if this number is 2, the number here should be at least 6. That means square root of 36, right? And apparently square root of 21 is less than square root of 36. So this number here is less than 2. If this number is less than 2, then when you -2 here, when you have a -2 here, the whole number here is a negative number, right? Can you see that? Okay, so if the whole number here is a negative number, so this number must be somewhere here, right? Well, let's say this number here is -2 plus square root of 21 over 3. All right, so that means we have the vertex and now 2 X-intercepts and a Y-intercept, which is here, 0, -5. So 1, 2, 3, 4. We have 4 points already, right? And last, let's consider the value of A. So here, value of A is -3. So A is -3, which is less than 0. So this function opens down, right? Okay, so that means from the vertex, it's opening down. That means it has a sketch like this, right? You should cross these points on the graph. Do you understand?
Yes.
Okay, now let's label the curve with its expression. Okay, so this is a complete sketch of this function. And again, if you want to label its axis of symmetry, the line has a function of x equals -2. All right, so please have a look at this question. And let me know if we can proceed to the next one.
Okay.
All right. Okay, now let's consider question 5. All right, again, if you want to sketch this graph, you need to convert it to a vertex form, which has a form like y equals a times x minus h squared plus k, right? And apparently, when the leading coefficient here is not 1, you can put it outside the brackets, which is y equals 3 times x squared minus 4x then plus 4, right? And then you need to consider the expression in the brackets. And we have already had x squared in the first term, And apparently the term in the middle can be rewritten as 2 times x times -2, right? So this is your b, right? So we can try rewrite this as x minus 2 squared. And if you expand it on a scratch paper, you will find that's actually x squared minus 2ab, which is 4x, then plus 4, right? Which is exactly the terms in this brackets. So that means we can rewrite it like this. Y equals 3 times x minus 2 squared, right? Understand?
Yeah.
Okay, so now it's already in the form of the context form, right? So this is the leading coefficient A. So apparently A is 3 and H is 2. And there is no K. Actually, K is 0, right? So you can treat it like plus 0. So K here is 0. So that means the coordinates of the vertex is 2, 0. This is the first step, done, right? And next, let's try to find its y-intercept, which means we need to let x be 0. And if x is 0, let's put it in the original expression. That means y equals 0 minus 0 plus 12, which is 0, right? Therefore, the y-intercept, coordinates of the y-intercept is 0, 12. And next, let's try to find its x-intercepts, if any. That means let y be 0 to solve for x, right? If y is 0, let's put it in the transformed expression. That means 0 equals 3 times x minus 2 squared, right? And apparently x is 2. Therefore, we have found its x-intercept. There is only one, right? Which has a coordinate of 2, 0. Last, step 4 is to find the value of a. A is 3. Apparently, this is greater than 0. When a is greater than 0, the quadratic equation will have a form like this. Opens up, right? Okay, so now we can sketch the graph of this function. Y-axis, x-axis. So first of all, the vertex is 2, 0. So 1 is here, 2 is here. Vertex is 2, 0. That means this is a vertex. And from the vertex, then we found that the y-intercept is 0, 12. So 0, 12 is about here. This is a y-intercept, right? And x-intercept is 2, 0, is also the vertex. So that means starting from the vertex, it opens up. So it will have a shape like this, right? Let's try to make it smoother. Okay, and this is the axis of symmetry, which has the equation of x equals 2. And usually we'll label the curve with its expression. Okay, so this is a complete sketch of the quadratic function. Please have a look at this and let me know if you can proceed to the next one, okay?
Okay, got it.
Okay, let's see the next one. Last question. Again, when you have a leading coefficient that is negative, you need to pay special attention, okay? First of all, we can put -2 outside brackets, and what's left there is x squared -2x, then +1, right? And we have already had our x squared, and we can rewrite the term in the middle. -2x, apparently this is 2 times x times -1, right? So this is our b. So you can try x -1 squared to substitute the expression in brackets. And if you expand it, it will get x squared minus 2x plus 1. And it is obvious that this expression here is exactly the same with the expression here in the brackets. So that means this is rewritten as -2 times x minus 1 squared, right? Which is y equals -2 times x minus 1 squared. And again, this is already in vertex form. So we need to find our AHK. Leading coefficient A is -2, and H is 1. And this is +0, right? So that means K is 0. Therefore, the coordinates of the vertex is 1, 0, right? Okay, so now we can label the vertex first on the 2D Cartesian plane. So 1 is here. This is a 1, 0. And this is vertex, right? Okay, second step is to find its y-intercept. That means let x be 0. If x is 0, let's put it in the original expressions. 1 is -2. Therefore, the y-intercept is 0, -2, right? Okay, next we can let y be 0 to find value of x. If y is 0, that means x minus 1 squared times -2 is 0. Therefore, the solution is x equals 1, right? And therefore, the x-intercept is 1, 0. Okay, so let's label these points on the graph. So first of all, y-intercept is 0, -2. So 0, -2 is here. And x-intercept is the same with the vertex here. Basically, we have found the vertex here, and which is also the x-intercept, and then the y-intercept is here, right? So last, let's check the value of a. So a, as we have already discussed here, a is -2, which is less than 0, right? When a is less than 0, this function opens up, so it has shape like this. Okay, so now we can complete the sketch. So this is a vertex and opens up and crosses this point. So basically it has shape like this. This is our function y equals -2x squared plus 4x -2. And the axis of symmetry is apparently x equals 1, right? Okay, so please have a look at this question and let me know if you finish, okay?
Okay.
Okay, so these are the questions of previous assignment. Before you leave, Today, I think we shall learn something new. Okay, a bit of something new. Okay, a pen and page. All right. So what I want to say is, suppose I give you a quadratic function here, which is y equals ax squared plus bx plus c, where a, b, c are all real numbers and a is not 0. And this is apparently a quadratic function, right? And this form is also called the general form. And if I give you the function like this, can you tell me what is the coordinates of the vertex? Is it possible? Okay, I'll give you 1 minute to think about this question. You are given a function like this. Can you tell what is the coordinates of the vertex? So apparently this is a quadratic function, right? Quadratic function either opens down or opens up. But in either way, it will have a vertex, right? The question is, what are the coordinates of vertex? Excuse me?
Is it b over 2a?
B over 2a, right? How did you get this? And how about the y coordinates of the vertex? For a point, usually will have 2 coordinates, right?
You just plug it in.
Plug it in, okay? All right, so let's study it from the very beginning. So if you want to find the coordinates of vertex, you need to convert it to a vertex form, right? Which has a form like y equals a times x minus h plus h squared plus k, right? Then its vertex is hk, right? So how we can do this? If the leading coefficient is a, first of all, we can put a outside brackets, right? What's left there is a plus b over ax, then c over a, right? Can you follow me?
Yes.
Okay, so can we rewrite the expression here to a squared binomial? That means something like m plus n squared. Can we do that?
Yes.
Yes, right? We need to rewrite term in the middle to 2 times x then times something, right? And apparently this is 2 times x times b over 2a, right? So if x is our m, then b over 2a is our n, right? Well, let's try rewrite this like x plus b over 2a squared. And before we proceed, let's verify if we expand it, what we'll get. So if you expand it on scratch paper, you will get x squared plus 2ab, which means 2x times b over 2a, right? And then plus n squared, which is b squared over 4a squared, right? Okay, so 2 cancels with 2 here. And as you can see here, the first 2 terms are exactly the same with the first 2 terms here in the original expression, right? But you introduced an extra term here. So that means you need to subtract it here in order to make this part exactly the same with the first 2 terms, right? Then copy the rest of the expression. Then that means this part is exactly the same with this part. Can you see that? Can you follow me?
Yes.
Okay, so next, we just need to simplify all the terms in the brackets, right? So that means x plus b over 2a squared. Then rewrite these two terms with a common denominator, which is negative b squared over 4a squared, then plus 4a squared is the common denominator, c times a 4a, right? And next, y equals a times x plus b over 2a squared, then positive 4a squared is the denominator, and 4ac minus b squared. Can you follow me?
Yes.
So is this already in a vertex form? Not yet, right? So we need to write one more step. That is to multiply a inside brackets. This means a times x plus b over 2a squared, and then plus 4ac minus b squared over 4a, right? Can you follow me?
Yes.
And is this form already a vertex form?
Yes.
The answer is yes, right? So can you tell me if it's in a vertex form, what are the three coefficients a, h, and k?
A is just
H is
A.
a here, right?
H is B over 2A.
No,
K
vertex form
is
has,
4A.
sorry, excuse me. Vertex form has a form like this, a times a minus h squared plus k,
Oh,
right?
negative B over 2A.
So h is negative b over 2a, right? So pay special attention here. This is negative. Do not forget the negative symbol. So how about k?
It's just the last part.
Yes, this is the last part, right? K is 4a is the denominator, and 4ac minus b squared is the numerator. So now we have our a, h, and k, right? So can you tell me the coordinates of the vertex now?
It's negative B over 2A and 4AC minus B squared over 4A.
Yes, that's correct. So what does this question tell us? It tells you that if you have a function like this, y equals ax squared plus bx plus c, if you want only its coordinates of vertex, you do not need to start from to solve it from the very beginning, right? You can just use negative b over 2a and 4ac minus b squared over 4a to get its coordinates of vertex. Do you understand?
Yes.
Okay, now let's do a practice. So let's consider this y equals, how about 2x squared plus 3x minus 10? What are the coordinates of vertex?
Negative 3 over 2, 4, 2.
2, right?
Yes.
So x coordinate of the vertex is negative 3 over 4, right?
Yes.
How about the y coordinate? You remember that?
4AC over 4. 8. No,
which is 4 by 2.
2,
Y.
10,
right?
negative 10,
Then
minus 3
4.
squared over 4 times 2,
Which is 8, right?
negative 72 over 8.
Is it 72? 4 by 2 is
Oh no,
8.
89,
89.
negative 89.
Okay, so the coordinates of the vertex is negative 3 over 4, negative 89 over 8, right? So that means if you only want the coordinates of the vertex, you can use this formula, right? Did you get it?
Yes.
And can you tell me, is it opening up or opening down?
It's opening up.
Up, right? Because you only need to check the leading coefficient, right?
Yes.
This is your A. If the leading coefficient is greater than 0, and then it will open up. Okay, so that means if you do not want to explicitly draw the graph on the coordinates, you can roughly draw it like this. First of all, the coordinates is negative 3 over 4. Y coordinate is also negative, so the vertex is around here, right? And it opens up, so it will have a shape probably like this, right? And without actually solving it, you can immediately tell that it will have 2 real roots, right? Did you get it?
Yes.
Okay. I hope you can understand what I mean here. Let's do another practice then. So how about y equals, okay, I'll write something randomly, okay? So how about 3x squared plus, okay, this time let's try a negative leading coefficient, negative 3x squared, negative 4x, then plus 8. So first of all, can you tell me the coordinates of the vertex?
Negative b over 2a, which is equal to negative 4 over 2 times negative 3, which is equal to 4 over negative 6.
Which can be simplified to negative 2 over 3, right?
Mm-hmm.
Okay.
And then
x, and how about y?
4ac minus b squared over 4a equals 4 times negative 3 times 8 minus b, which is negative 4 squared over 4 times negative 3.
Which
negative 84, 96 plus
3 by
16.
3 by 2 is 12. 12 by 8 is 96, right?
Yeah. Plus 16.
Plus or negative? A plus or
Oh, negative 16 my negative 12.
Okay, then simplify.
80. I mean 70.
No, for how about the numerator?
Negative 7.
Right?
Oh, never mind. And then negative 12.
Okay, so the 112 over 12 is how about
2 and then 32, 8, 16, 28. Okay.
28,
Over
right?
3.
3. Okay, so the vertex is negative 2 over 3 and 28 over 3, right?
Yes.
Okay, and how about the direction?
It goes down.
Opens down because the leading coefficient is negative 3, right?
Yes.
So can you quickly tell me, does it have 1 root, 2 roots, or no root? I mean, in a real number set. To check that, first of all, draw x-axis, right? You do not need to draw the y-axis because you don't know where is the y-intercept yet. So just draw the x-axis. So first of all, the vertex is here, right?
Yes.
Because the y coordinates is more than 0, so it must be above the x-axis. And then it opens up or down?
Down.
Down. So this is a vertex and opens down. So that means it must have 2 different real roots, right?
Yes.
Okay, so this is what I want to illustrate. So sometimes if you want to only, first of all, if you want to only have the coordinates of the vertex, you can use this method, right? Follow me? Okay, so
yes,
this takeaway number 1. And takeaway number 2 is if you want to only quickly check whether it has 2 or 1 or 0 roots, you can then draw the vertex, sketch the vertex first, and then according to the direction of the curve to find whether it will have 2 or 1 or 0 roots. Understand? Okay. All right. So I'll upload the new homework to Google Classroom. Okay. So probably tomorrow I'll let you know when it's ready on the Google Classroom. Okay. Okay. So now you're free to leave. Happy New Year.
Thank you. You too. Bye.
Bye. See you.